Okay, another situation on Venn diagrams. So we've got a Venn diagram here where you've got your universal set, and then you've got set X and set Y. The intersection between set X and set Y is got P there, right? So the number of items in the intersection of set X and set Y is P. And then you've got R, which represents the number of items that are not in set X and also not in set Y. So what is the information we're given in this particular example? The number of elements within the universal set is 70. So the total number of all the elements is 70. The number of elements in X is 30, and the number of elements in Y is 20. That's what we have there, right? So what is the question? The question is, what is the maximum possible value of P? What is the maximum possible value of P? And part B, what is the minimum possible value of R? So let's start off by P. For P, we're exploring the maximum value. What's the largest number that P can be? Now, the first thing we need to look at are the constraints. What are the limits of what P can be? The limits are the sets X and Y. The set X can hold up to 30, and the set Y can only hold up to 20. So if P is going to be a number that fits inside both set X and set Y, it must satisfy both constraints or both limits. It must be not more than 30. At the same time, it must not be more than 20. Since 20 is a smaller number, then the biggest that P can be is the maximum value P can be is 20. P cannot be 21. Why are we saying P cannot be 21? Because the set Y holds a maximum of 20. So if P were 21, it would no longer fit in set Y. And so that's why we say that's the maximum value that P can be. You just look at the set that holds the smaller number, and that's what happens. So P cannot be 21 or any number above 20 because it would no longer be fitting inside the set Y. The next question is, what is the minimum possible value of R? So if you look where R is, this is R. We're looking at the smallest that R can be. Now, first of all, we know that the universal set contains a total of 70, right? If I add everything, the total is 70. So for R to be very small, right? If we're going to make R very small, it means of this 70, most of it must have been used up here. Most of it must be here, so that if we say 70 minus whatever is here, we get a very small value of R. Now, how do you get a large number here? You get a large number here when the two sets X and Y are actually separate. If set X and set Y are not sharing any elements, in other words, if P is 0, if there's nothing in the intersection region, then you get the maximum value. Because if P is 0, it means of the total 30 inside set X, the entire 30 is here. Of the total 20 inside set Y, the entire 20 is there. So these two sets will then add up to give you a 50. Right? Now, knowing that the total of the universal set is 70, I'll just say 70 minus 50 to get the smallest value R can be. So the smallest value R can be is going to be 70 minus 50, and that gives you 20. That's the smallest value R can be.